Hello everyone, and welcome to this session on DBMS and key database terminologies. In this tutorial, we will introduce you to the basics of DBMS and key database terminologies. So let's start with the basics. Now, before we dive into DBMS, let's take a moment to understand what is data and information. So the data is a collection of raw facts, figures such as numbers, text, or images. It's meaningless on its own and needs to be processed to make sense. Now, what is information? So, the information is a processed data that is meaningful to the user. When we process data and turn it into meaningful insights, we get information. So, we have seen what is data and information, and now let's see what is a DBMS. So, a database management system is a system software that lets you create, maintain, and manage databases. Now, what is a database? A database is a collection of data that is organized in a particular way. Now, it's not only collection of data where data will be stored in tables. Along with the data, it might hold other objects like views, indexes, triggers, user-defined types, and cursors. Now, the DBMS provides an interface between you and the database, which lets you access and manipulate, that is, create, insert, or delete, update the data in the databases. Now that we know what a DBMS is, let's discuss some basic terminology that you will encounter when working with DBMS. So, first terminology that we will be discussing is a table. So, what is a table? A table is a collection of data organized into rows and columns. So, these are the rows and these are the columns. Okay. Now, each row in a table represents a record. Each row in a table represents a record and each column represents a field. So table will have a table name and rows and columns. Let's talk about field, which is also known as column or attribute. So in this example, you can see a field is a single piece of data stored in a table. For example, this one or this particular cell, which is storing the name of employee Mike. So these are nothing but fields. These are the columns which holds the particular value, a single piece of value. So these are the columns, also known as attribute, also known as fields. Now let's talk about the row, or also called as record, or also known as tuple. So record is basically a set of related data stored in a table. For example, here, a record in an employee table contains information about particular employees. For example, their employee ID, name, and department. So these three, Paul and 20 collectively makes a record. The most commonly used terminology in the database is a primary key. So what is a primary key? A primary key is a unique identifier for a record in a table. Now, it can be a single field or a combination of fields. The primary key is used to ensure that each record in the table is unique. So in the employee table, employee ID is a primary key because it uniquely identifies each record. Whereas let's look at employee name. So there are two employees having same employee name whose name is Paul. So we cannot use this name as a primary key because this is not uniquely identifying a row, right? So if you write a query, select star from employee where emp underscore name is equal to Paul, you'll get two row. And that's the reason it's not a good candidate for a primary key, right? So primary key is a unique identifier for a record in the table. Another important terminology used in database is a foreign key. So what is foreign key? A foreign key is a field in one table that refers to the primary key in another table. It is used basically to link the records in different table. Now, when foreign key comes into picture, there are two referential constraints which are important to understand. For example, if you want to delete a primary key which is having a child records into the referred table, you need to set integrity constraint, which will either delete this child records or it will set those values to the null. So first integrity constraint is on delete cascade. So on delete cascade will automatically delete corresponding rows in the child table. For example, if we'll try to delete this row where department ID is 10, before deleting this row, it will delete these two childs and then it will delete the parent row. Similarly, if you do not want to delete the child rows, but instead you want to remove their department number, you can also do that by using on delete set null. How to do that? It's basically while creating a referential constraint, you need to set the on delete set null clause. So when you will set on delete set null clause, it will set the foreign key value to null in the child table when a row is deleted from the parent table. Thank you for joining us on this journey to learn about DBMS and its key terminologies. If you have any question or feedback, please feel free to leave a comment below. We would be happy to hear from you. Thank you.